are connected to the ohms. Now we can turn it on. We're just going to connect those directly to our positive and our negative. Okay? That's going to be the resistance for resistor 1. You're going to dial it down until you get 3 digits. Okay? So that is going to be the resistance that we get for resistor 1. To find the resistor for 2, you just plug it in directly to that resistance. Okay? So you're going to find the resistance. I'm going to ask for the resistance for each of the resistors. Okay? Then I'll also ask what is the resistance for the entire circuit. Okay? So you can just measure the resistance for everything right away because I'm going to have circuits that have 1 through 4 anyways. Okay? So once you find the resistance for all of those, then we're going to find the resistance for the circuit. So we're going to go and hook up our circuit. The first circuit that we have is going to be our series circuit with our R1 and our R2. Okay? So our series, we're going to connect our tail to the head, and then we always do the power supply last. Okay? So we connect our R1 tail to the R2 head, and all that we have left is going to be the power supply. Okay? We're finding resistance, so we don't have a power supply. We imagine this is our power supply. Okay? So all we have left is connect to our beginning of the circuit, the end of the circuit, and then that's going to be the resistance that you get for the circuit. Okay? So that's going to be the resistance for our first circuit that we have. Now we're going to find the resistance for our parallel. So we connect our parallel circuits head to head, tail to tail. Okay? So our positive side is our head, our negative side is our tail. So we're going to connect our positive to our positive, our head to head, negative to negative, tail to tail. Now we can go and hook up our natural power supply that we have to find our resistance for the circuit. Okay? So we go to the beginning of the circuit, the end of the circuit, and we're going to get the natural resistance for the circuit. Okay? For parallel, it doesn't matter if you connect it to this one or that one. Okay? The reason being is because they're connected by the same wire. They're linked together. So same thing with our negative. It doesn't matter if we connect it to either side of the tail, okay? Because they're linked to the same portion. Okay? So this is how we find the resistance for our parallel circuit. Okay? We're going to find our resistance for our series circuit. So what we have here is we have our R1 is in series with our parallel of 2 and 3, which is in series with our 4. Okay? So power supply goes last. We have R1 is in series with our R2 and 3, which are both in parallel. So we go our head to head and our tail to tail.
We could do the parallel first and then the series, right? It won't matter.
No, it doesn't matter. Yep. Yeah, so you can go ahead and, as Jessica said, you could do your parallel first and then connect your series last. Okay. After that, we have R1 is in series with our parallel of 2 and 3. So lastly, we just have to have our series with our R4. So we connect our tail of R3 to the head of R4. Okay. And again, if they're linked together in parallel, doesn't matter which tail I connect to. Okay? It could be the tail of R3 or the tail of R4. Okay? So that doesn't matter either. Okay? Lastly, all we have to do is connect our natural power supply to find the resistance for this circuit. So we just connect our positive to positive, negative to negative. Okay? And that's going to be the rundown for the resistance. Okay? Once we do that, we're going to select our dial to be in the volts because we're already in that section there. So now we're going to find the volts. From here on out, you have to have your circuit connected to a power supply. Okay? The resistance is the only time where you're going to have this bare. Okay? So for the volts and the current, you have to be selected to your power supply. Okay? So you have to have your circuit turned on. Okay? So we're going to do the first one, which is going to be our series circuit of R1 and R2. Okay. Now we have to connect our power supply last. Positive goes to positive. Negative goes to negative. Okay. Now we can turn on our circuit. Now that we have the circuit turned on, now we can find what the volts is. So just like your battery in your car, to find the voltage for the battery in your car, all you have to do is find the potential difference, which is the difference between your positive and your negative terminal. That's going to be how we find the total voltage. Okay?
Of the system.
Of the circuit, exactly. So for our series circuit, what it says is that our voltage is split. Okay, so for our series circuit, our total voltage is equal to the sum of each of the series resistors. Okay? So now we're going to verify that. We have 5.1 as our total voltage. We're going to find our positive and negative, the potential difference between R1. We get 3.5, okay? Is going to be the potential difference, also known as the voltage, okay, between resistor 1. So the total is equal to the voltage of R1 plus R2. So if we have R1 is 3.5, we know that R2 is going to be 1.6, and we can verify that by plugging our positive to positive, negative to negative to find the potential difference between that resistor. We get 1.6. Questions for that? No? So that is how we find the voltage for our series circuit. Okay. Now we're going to find the voltage for our parallel circuit. Disconnect your power, go tail to tail, go head to head. Connect your power back up. Positive goes to the positive. They're in parallel, so it doesn't matter which. Negative to negative, doesn't matter which. So our positive flows from the positive to the head of resistor 1 and 2 because they're linked up, through both of those resistors to the tail. The tail is connected back to the battery, so we can turn on our circuit. So we're going to measure the voltage again for the entire circuit, directed to the positive and negative. We get to 5.1. We can disconnect, and all we have to do is the same thing as what we did before. We're just finding the potential difference between the resistor. So positive to positive, negative to negative for those resistors, you get the voltage. So for our parallel circuits, our voltage is going to be the same, but our current's going to drop. It's going to be the sum equals to the total current that we get for that circuit, okay, for parallel. Okay, so we can go ahead and verify that we get 5.1 for resistor 2. Okay, we get 5.1, so we verify that the voltage is the same. Okay, you're going to do the same for your circuit 3, and now we're going to go over one last thing, and that's going to be our current. Disconnect your power source. For current, we have to be on our capital A, positive to positive, negative to negative. We're going to turn it to our 2A. We have to be on our solid A. There's a line next to the A. That means our direct current. If you have a sine graph, a squiggly line, that means alternating current. Okay?
So what is it, this direct line you said?
A solid line is for DC. So a squiggly line, it's a sine graph. It means our alternating current. So
Which one we want to use? DC.
the DC, only DC. And it's listed here so you can remember. 5 volts DC. Okay? So we're going to do the first one, find the current. First one is our series between R1 and R2. That's just left with our positive and negative. We can turn on our circuit. So to find the current for that system, all we have to do is make a break. We only make a break on the heads. Okay? So we make a break on that circuit, connect it to the positive. So our current runs from our positive into the meter. Our digital multimeter has a meter in there that spins. It stops once we get to the equilibrium. We have to go back to where we broke it, okay? And that's going to be the current that we get, okay? When your first resistor is in series, there's only one way to measure the total current and the current through resistor 1, and that's by breaking this head, okay? Because there's only one wire coming from it. So you always make the break from the head coming from the power source, okay? Whether it's parallel or it's series, okay? It's all the same, all right? So we can turn it off. Now we can go ahead and verify what our current is through our R2. Should be the same of our 0.0032. We only make the break from the head. This goes back where?
To where you made the break.
To the break, perfect. We get 0.0032. Questions on that?
So you didn't do the whole circuit, right? Yeah.
We did. So since the first one is in series,
Oh,
there's
for
only
series,
one
okay.
way to find the total current and the current through R1. Okay, and that's by disconnecting the power source, but we can only disconnect from the head side. Okay, so the last one that we will go over is going to be the current for our parallel circuit. Okay, so disconnect your power source, connect your circuit back up, positive to positive, negative to negative. Lastly, we go our power supply. Doesn't matter which because they're both in parallel. They're linked together. It's easiest just to go and plug to the first one. Okay? So to find the current, you're going to turn it on. You're going to find the current through the entire circuit here. So just as we did before, you only disconnect the wire that comes from the positive terminal of the power supply. Okay? This is for the total current. Connect it to your wire. This goes back where?
Where you made the break.
Where we made the break, which is right here. Okay? This is going to be the total current. Okay? So like I said, it doesn't matter which one you broke it from. We can go and put the break onto this one. Okay? But just put the break back to where you put it. But this just shows proof that you get the same current.
So you don't touch that wire, right?
No, you never touch these wires. Okay? So that's going to be the total current through the circuit. Lastly is going to be finding the current through each of the resistors. Okay? So our circuit's back to how it was. Okay? Now we can find what the current is through each of the resistor. So to find the current through a parallel resistor, okay, you have to disconnect the entire head. Okay? So if I disconnect this one, I'm finding the current through the whole circuit. If I disconnect the entire head, that's going to be the current through that resistor. Connect it here, so it goes from our positive into here. This flows back into here, so we're separating our current right now. Okay? It's flowing back into our meter, meter comes back into here. This goes back to where we broke it. Okay? And that's going to be the current that we get. Okay? So the total current, our 0.014 something, okay, is equal to, we already found the total, which was 0.014. Okay? The total is equal to the sum of both of those currents. Okay? So we get 0.0046, which means that our current through resistor 2 should be 0.01. Okay? We have to disconnect the entire head, connect it to the positive side of our ammeter. This goes back where?
Break.
To the break. Okay, we get 0.01. Questions? So that, yes. Questions? No?
Can we do the same with the voltage? Like, break the...
No. So voltage, just plug it in directly. It's potential difference. That's the way to remember it.